Hello, and welcome to the first Lunabotics video update. This is the Lunabotics team. My name is Dan Gower, and I am the Lunabotics team lead and the team leader of the Mechanical Senior Design Team. These are the Mechanical Senior Design Team members. From left to right, Kaylee Robertson, Perry Orthy, and James Sweeson. Our first project of the year was remodeling the Lunabotics lab in Anderson Hall. We first moved all of the furniture to make the space more useful. We added pegboards to both the mechanical and electrical workbenches to organize all of our tools and instruments. We then created a conference table so we had a platform for more effective meetings. Wasting no time, we continued working on the design document we had started in the spring semester. The Lunabotics competition rules were released just before the school year started, so our first task was to take our design and ensure its compliance with the rules. We started by taking the frame we had been given from last year's team and deciding whether or not we would be able to use it in our design. We decided to go with a modular design, so this frame would work as we would be designing subframes that would attach to this frame. These are the 8 mounting points we identified for the mechanical seam sections, both collection and dumping. This is the first rendering of our design, done in SolidWorks. It is comprised of 3 major mechanical components. The first is the bucket conveyor collection system, which will mount to our frame at 4 points via a subframe. The subframe is not shown as it hinders the view of the bucket conveyor collection system. This right here is the frame of the bucket conveyor collection system that is a unique design and allows us to have 2 buckets digging at the same time. These are the buckets. You'll notice a larger gap in between the top 2 buckets on the left-hand side. This allows us to have no buckets on the bottom when we need to transverse the obstacle field at the competition. The second major component is the dumping system. This is comprised of one single conveyor belt with horizontal slats to facilitate the moving of the lunar regolith or dirt out of our robot. The way it works is there are sidewalls that are not shown in this image as they would block the conveyor belt that hold the dirt on top of the conveyor. We'll then back up to the dumping bin, the conveyor will turn on and will offload all of the lunar regolith or dirt that we have collected. Shown here are the 2 mounting points for the rear dumping system. There are 2 on the other side that are not visible in this image. A subframe will connect to these 2 mounting points and our conveyor dumping system to make it easy to remove and service the part should we need to. The third major mechanical component of our robot is the drive system. After analyzing robots that have been successful at this competition and through our own research, we decided to go with wheels over treads, as wheels seem to be the more effective option. We will be using a single belt drive motor to drive all 3 wheels at the same time. Each side will be independent of each other, so the robot will operate much like your standard skid steer. Currently, we have just finished making our first purchase order request. The total that we are requesting is $1,000, the first $500 of which will be coming from our senior design budget allotment. The remainder will be coming from Dr. Halferty's space grants through NASA. We are also working on finalizing our design document, which will be submitted to senior design on October 18th. This concludes our first video update. Thank you so much for watching and look for an update in the next 2 weeks.